In problem number 10, there are two models here. Metal rods are modeled as perfect cylinder with radius 1 centimeter. They are packed into a box in two different ways. In method 1, a repeating unit is shown in the following diagram. The repetition unit contains 4 quarter circles and 1 full circle. Explain why the diagonal of the square has a length which is equal to 4 cm. Now the radius is 1, here 1, and 1 here. So that will be for 2 quarter circles. You'll have a unit which is equal to 1 unit, and then plus 1 full circle. The diameter here is, so 1, 1. The diameter is equal to we'll have here 2 for the 2 quarter circles, and for 1 full circle each 2. So this is equal to 4. Okay, this will be also the diagonal of the whole circle. For letter B, explain the proportion of the box which is filled with metal. So proportion shall be the area of the box and the area of the metal. So let's first find the area of the box. Since this one is equal to 4, so the whole thing is 4. So let's call this x and x. Uh, so by formula, Pythagorean theorem, x squared, actually the area is equal to x squared. Let me erase this. But what is the value of this x squared? So using Pythagorean theorem, x squared plus x squared equals 4 squared, which is 16. So this gives us 2x squared equals 16. So x squared equals 8. So area of that, which is x squared, is 8. Area of the metal is 4 complete, 4 quarter circle is 1 circle, and then we have another circle, so we have 2 circles. And the area of this is pi r squared times 2. So 2 pi, but our r is 1 squared, so it's equal to 2, 2 pi. 2 pi. So the proportion of the metal is 2 pi over 8. I can probably change color here. So area of the metal is 2 pi over the area of the box is 8 as shown in the solutions. So it's equal to pi over 4. That's the proportion. State any assumption required in your answer in part B. So we assume that extra space is negligible. That's really the negligible. That's really the actual dimension. In method 2, a repeated unit is shown in the following diagram. So if there is a gap here, we try to close it in here. Again, the diagonal will still be 4, of course, same thing. Find the proportion of the box which contains metal in method 2. So for letter D again, we're getting the proportion of the box. So the proportion that is metal over the proportion that is the area of the box. There will be a change in area because there is a compression. So this is since this is 1 and this is 1, so the whole thing here is 2. So let's find the value of, it becomes a rectangle now where the area of the box is x times y, where our x is 2 and our y is unknown. This is the y, this is the x, and the area is unknown. Okay, so we can also use the Pythagorean theorem where x squared plus y squared equals 4 squared. So we have 4 plus y squared equals 16. Our y squared here is uh, 16 minus 4, 12. So that's y squared. So our y equals square root of 12. So in this manner, our area, which is xy, so area, which is xy, shall be 2 times square root of 12. So I can write here 2 square root of 12. The area of the metal is the same as before, which is 2 pi. So the proportion shall be pi over square root of 12, canceling this out. Okay. So for letter E, determine with justification whether method 1 or method 2 packs more rods into the same box. We're going to uh, for the first one, ito yung first, second, they pack the same 2 pi over 8 here, 2 pi over 12 over 2 square root of 12. So we can compare the two. So we know that if uh, we have the same denominator, so we can just compare the denominator. The less is the denominator, greater is the value of your numerator. But here we have the same numerator, meaning to say the same two circles could be packed at 8 or could be packed over 2 square root of 12. But we have to compare 2 square root of 12 is less than 8. 2 square root of 12 is less than 8. Meaning to say, the one that carries 2 square root of 12 will have greater numerator. So this one will have great numerator. So we say method 2 can pack more rods.